Hi everyone, in this video I'm going to solve Cambridge International AS and A-Level Mathematics Paper 1 Pure Mathematics 1 in a session May-June 2022 Paper 1-1. So let's start with the first question. Question number 1 Part A, express the standard form of a quadratic equation in the form the vertex where P and Q are constants. So whenever we convert the standard to the vertex form, we have to use a completing square method. Completing square method. Okay, so in completing square method, the first thing is to write down the standard form. In the first step, take the coefficient of x square common from the first term and the second term, and the third term is as it is. Now in the next step, just take the coefficient of x, which is negative 8, divided by 2, you will get some answer, negative 4, take its square, you will get 16. So add and subtract 16 inside the bracket. Now this is x square minus 8x plus 16 minus 16 and plus 11. Now combine the first three terms, x square minus 8x plus 16 and negative 16 and positive 11 is as it is, right? Now here we can complete the square. You can see this is x minus 4 whole square, and from 11 take away 16 is negative of 5. Now this is in the form of x plus p square and plus q. Q is negative 5 and p is negative 4. This is a required solution. Now for part B, hence find the exact solutions of the equation. This equals to 1. So we have converted this equation x square minus 8x plus 11 into this form. So we can write this down. Hence means use the answer from part A. This is x minus 4 whole square minus 5 would be equals to 1. X minus 4 whole square, this is 1 plus 5. X minus 4 whole square would be equals to 6. Okay, now we have to take a square root on both sides. So here we can do square root on both sides. And whenever we do the square root on both sides, it should be plus minus, right? X minus 4 whole square and the square root. This is plus minus square root of 6. Okay. And this square and the square root is cancelled out. X minus 4 would be equals to plus minus root 6. Right. So we have two solutions, x minus 4 equals to root 6, or we can say x minus 4 equals to minus root 6. So what are the two exact solutions? So here x would be equals to 4 plus root 6, and on the other hand x would be equals to 4 minus root 6. These are the two required solutions, the exact solutions, right? Question number 2, the 13th term of the arithmetic progression is 12. So T13 term 13, sorry, T13 is 12 and the sum of the first 30 terms is minus 15. So S30 is minus 15. Find the sum of first 50 terms of the progression. Okay, the sum of the first 50 terms, right? So this is an arithmetic progression. For arithmetic progression, the first thing we know is the term formula. The term formula is a plus n minus 1 into d, and the sum formula for arithmetic progression Sn is n by 2 into 2a plus n minus 1 into d. Okay, now we have given the 13th term and we have given the sum of first 30 terms, right? So T13 we have given, which is equals to 12 equals to a plus 13 minus 1 into d. So 12 equals to a plus 12d. This is my first equation. Now the sum of first 30 terms we have given, right? So this is S30 we have given, which is negative 15 equals to 30 divided by 2 into 2a plus 30 minus 1 is 29d. 2 times 15 is 30. So negative 15 equals to 15 2a plus 29d. This sum is cancelled out. Minus 1 equals to 2a plus 29d. This is your second equation. Now with the help of these two linear equations, we can get the value for a and d. Alright. So we can say from equation 1, the equation 1 is we can solve for a. So 12 minus 12d, this is your a value. That is my equation 3, right? We can say put equation 3 in equation 2 and solve for this d. Yeah. Minus 1 equals to 2 into the a value, which is 12 minus 12d plus 29d. Minus 1 equals to 2 times 12 is 24 minus 24d plus 29d. So minus 1 minus 24, this would be equals to 29, take away 24. 5. This is 5d. This is minus 25 is 5d. And minus 25 divided by 5, 5 times 5 is 25, negative 5 is the value for d. So d equals to minus 5. Okay. So we got the value for d. Now substitute this d value into your equation 3 to get a, right? Put d in equation number 3 and solve for a. So a is equals to 12 minus 12d. Minus 12 times minus 5 is 60. A would be equals to 12 plus 60, and 60 plus 12 is 72. So the A is 72. Now we got the A value and we got the D value. Back to the question, we need to figure out the sum of first 50 terms of the progression. S50 we need to just figure out. Okay. So here we can say S50, this would be equals to 50 divided by 2 into 2 times of A plus 50 minus 1 into the D value, which is negative 5. Just simplify, you will get the answer. From 50 take away 1 is 49. 49 multiplied by negative 5 is minus 245. So S50 minus 245, and what is 2 times 72 is 144, and 50 divided by 2 is 25. Okay, 144 minus 245 times 144, 25, sorry, minus 2525. So sum of the first 50 terms is negative of 2525. Question number 3, the coefficient of x4 in the expansion of this is a, and the coefficient of x square in the expansion of this is b. Part A, find a and b in terms of the constant k. Okay, so we need to figure out the coefficient of x4 in this expansion and the coefficient of x square in this expansion, right? So it is better to use a term formula, right? We know that the term formula of binomial expansion a plus b to the power n tr plus 1 is equals to ncr a to the power n minus r and b to the power r. So the first expansion is this. Okay, so we can say 2x square plus k square over x to the power 5. The a value is 2x square, the b value is k square over x, and the n value is 5, right? Now apply the term formula. Tr plus 1 is equals to n values 5 cr. The first term is a, which is 2x square. Its value is n minus r. And the second term is k square over x. And the whole term is r. So simplify. Tr plus 1 would be equals to 5 cr 2 to the power of 5 minus r k to the power 2r. This 2 to the power of 5 minus r and k to the power 2r. Now I'm solving for x. X to the power 2 times 5 is 10 minus 2 times r is 2r, and x to the power minus r. Shift into the numerator. So tr plus 1 is 5cr 2 to the power 5 minus r, k to the power 2r, and x to the power 10. 10 minus 2r and minus r is minus 3r. Okay, so in order to get the coefficient of x4, it means this should be equals to x4, right? For coefficient of x4, we can say 10 minus 3r, this should be equals to 4. Make it x to the power 4, right? So from here minus 3r would be equals to 4. Take away 10. Minus 3r is equals to negative of 6. Negative is cancelled with negative. 3 times 2 is 6. So the r value is 2. So just substitute r equals to 2 and you will get the put over here. So t2 plus 1 is 3 equals to 5 c2 2 to the power of 5 minus 2 k to the power of 2 into 2, and here x to the power 4. Okay, now let me simplify this. 5c2 is 5, c2 is 10, this is equals to 10, and 2 to the power 5 minus 3 would be 4, and here k to the power 2 times 2 is 4 and x 4. So this is 40. K4 is a coefficient of x4, right? Now we have given that the coefficient of x4 in this expansion is a, and we have to solve for a in terms of k, right? So coefficient of x to the power 4 is a. So what is the a value? In terms of k, the value of a is 40 k to the power 4. This is your a value in terms of k. Okay. Now let me open this expansion by using the term formula. We need to find out the coefficient of x square for this, right? Okay. Again, applying the term formula on 2kx and minus 1 to the power 4. So t r plus 1 is equals to n c r, the first term to the power of n minus r, and the second term to the power of r. Okay, now here we have tr plus 1 is equals to 4cr 2 to the power of 4 minus r, k to the power of 4 minus r, negative 1 to the power r, and x to the power of 4 minus r, right? So I split the 2 power, I split the k power, I split the x power, and this negative 1. Okay, now what we need to figure out? We need to figure out the coefficient of x square in this expansion, right? Okay, so for coefficient of x square, this should be square 4 minus r should be equals to 2, and solve for r. Minus r is 2 minus 4, So minus r is negative 2, and from here the r value is 2, right? So when r value is 2, so we have t 3 plus 1, 2 plus 1 is 3 equals to 4 cr 2 to the power of 4 minus r k to the power of 4 minus r minus 1 to the power of r, and this is x to the power 2. Okay. Simplify. What is 4c2? 4c2 is 6. So the third term would be this is 6, and 2 to the power of 4 minus 2 is 4, and here k to the power 2 minus 1 square is 1 x square, and 6 times 4 24. So the third term is 24k square is x square, right? Now what we have given that the coefficient of x square is b. So what is the value for b? So the b would be equals to 24k square. This is the value for b. In terms of k. Now for part B, given that a plus b is 216, find the possible values of k. A plus b. What is the a value? We have done the a value, which is 40k to the power 4, and the b value we have done is 24k square. Put this, their sum equals to 216. Wait a second. I solved this wrong. We know that 2 to the power 5 minus 2 is 3, which is 8. Oh, so 8 times 10 is 80. This is 80. Sorry. Now use this value of a and b, and their sum should be a value is 80k to the power 4, and the b value is 24k square, and this should be equals to 216. Okay, simplify 80k 4 plus 24k square minus 216. This should be equals to 0. Okay, so everything is divisible by 8. So let me divide everything by 8, divided by 8, divided by 8, divided by 8 on both sides. 8 times 10 is 80, k to the power 4. 8 times 3 is 24, k square. And what is 216 divided by 8 is 27, minus 27, this is equals to 0. Okay, now here we do the factorization. It is a quadratic equation in k square, right? So we have to do the factorization. 10 times 27. 10 times minus 27 is 270 with a negative. Now the factors of 270 and their sum should be equals to 3. All right. So we can do the factorization by, if you do 15 times 18 is 270, and if you do from 18 take away 15 is 3. 18 times minus 15 is minus 270, or 18 minus 15 is 3. You can also do solve the values of k by using quadratic formula. This is up to you. Let me factorize this. So 10k to the power 4, 3 split to 18 minus 15 plus 18k square minus 15k square minus 27 equals to 0. Now from here to 10 and 18, we can take 2 common. 2 times 5 is 10, 2 and k square is common, and 2 times 9 is 18. And you can take a negative sign common, and you can take 27, and we have 15 over here. So 3 times 5 is 15, 3 times 9 is 27, so 3 is common. 5k square plus 9, negative is already common. So the factors are 5k square plus 9 and the other factor is 2k square minus 3 equals to 0. Okay, now put both factors separately equals to 0. 5k square plus 9 is equals to 0, or we can say 2k square minus 3 is equals to 0. 5k square would be equals to negative 9 and k square would be equals to minus 9 by 5. And from here 2k square is equals to 3 and k square would be equals to 3 by 2. In order to get the value of k, we have to take a square root on both sides. Square root of this side and the square root of this side with the plus and minus. Okay, so here you will get k is equals to plus minus square root of negative 9 over 5. And on the other hand, here k would be equals to plus minus square root of 3 by 2. Okay, so here whenever in a square root we have a negative number, you will get the complex roots, or here you can say no solution from here. You can also check from the calculator that what is square root of minus 9 by 5. It's no solution. So no solution from here. This is the only values of k, which is plus minus square root of 3 by 2 or 1.5. These are the two possible values of k. Question number 4, part A, prove the identity left hand side equals to the right hand side. Okay, so let me start from the left hand side. Okay, the left hand side is sine cube theta over sine theta minus 1 minus sine square theta over 1 plus sine theta. Okay, so here we do the cross multiplication. Sine cube theta is multiplying with the opposite denominator 1 plus sine theta, and minus sine square theta is multiplying with the opposite denominator sine theta minus 1. Everything divide by, this is sine theta minus 1 and this is sine theta plus 1. Okay, now here we apply the difference of square formula. So first, sine cube theta into 1. Here this is sine 4 theta minus sine cube theta square into this, and we have a minus sine square theta, and whole divides a plus b into a minus b, a square minus b square. Use the formula of difference of square. A square minus b square, this would be equals to a plus b into a minus b. When you have two factors with a plus minus, apply the difference of square formulas. And now here we have open the bracket, sine cube theta plus sine 4 theta minus sine cube theta plus sine square theta, everything divided by sine square theta minus 1. Okay, now sine cube with sine cube, positive and negative is cancelled out. Here we are left with sine 4 theta plus sine square theta, and in the denominator we are left with sine square theta minus 1. Okay, so further we can simplify. We can simplify this taking sine common. Sine square theta is common, so when you take sine square theta common, we are left with sine square theta plus 1. So you guys can see we have made it 1 plus sine square theta, but this should be minus tangent square. Okay, divided by sine square theta minus 1. Okay, let me use the identity that cos square theta plus sine square theta is equals to 1. Okay, and what is the value for sine square theta? Sine square theta is equals to 1 minus cos square, but it should be in cos. Yes, 1 minus cos square theta. Just write down this value of sine square theta as 1 minus cos square. This implies we have sine square theta into sine square theta plus 1, divides, we have sine square theta is 1 minus cos square theta, and this is minus 1 is as it is, right? Now we can cancel the like terms, plus 1 and minus 1, and we are left with sine square theta into 1 plus sine square theta divides minus cos square theta. We can write this down as sine square theta over cos square theta. The negative sign is over here into 1 plus sine square theta, and sine over cos is a ratio for tangent, so minus tangent square theta into 1 plus sine square theta. This is exactly the same as your right hand side, minus tangent square into 1 plus sine square theta. Okay. Moving to part B, hence solve the equation means use the answer from part A. This whole thing equals to tan square 1 minus tan square theta. Okay, so we know that this whole thing is equals to this, right? Pi theta values from 0 to 2 pi, keep it in mind. Okay, so minus tangent square theta into 1 plus sine theta, sine square theta, this would be equals to tangent square theta into 1 minus sine square theta. Okay, let me simplify. So it is minus tangent square theta minus tangent square theta into sine square theta. This is tangent square theta minus tangent square theta into sine theta, sine square theta, right? Tangent into one tangent with sine, tangent into one tangent with minus sine. Shift every term to the left side. Minus tangent square theta minus tangent square theta sine square theta. This minus tan square and plus tan square sine square. This is equals to 0, right? Now we can cancel this is with plus, and this term with the minus is cancelled out, and we are left with minus 2 tangent square theta equals to 0. Okay, and tangent square theta would be equals to 0 over minus 2. Tangent square theta is equals to 0, right? Taking a square root on both sides, plus minus 0. So from here tangent theta is equals to 0. From 0 to 2 pi the domain, right? Let me solve for the base angle first. For the base angle, we can do theta is tangent inverse of 0. It is in radians, right? From 0 to 2 pi. Calculator is in degrees. Now it is in radian mod. Tangent inverse of 0 is 0. So theta equals to 0, right? Now we have to check here. Tangent is positive. Apply, draw the coordinate diagram and check tangent is positive in which quadrant. Okay, the domain is from 0 to 2 pi. So in first quadrant, all trigonometric ratios are positive. In second, sine is positive. In third, tangent is positive. And fourth, cos is positive. The first quadrant, theta is the base angle. Here pi minus base angle. Here pi plus base angle. And here 2 pi minus base angle, right? Okay, now tangent is positive in the first and in the third quadrant, right? Tangent is positive in first and third quadrant according to the given domain. So we can say that tan is positive in first quadrant and it is also positive in the third quadrant. So what is the value for the first quadrant? For the first quadrant, the theta is the base angle, which is 0. And for the third quadrant, what is your theta, which is pi minus the base angle, which is just pi. Okay, so here we have two solutions, 0 or pi. As you can see, 0 is not included into the domain. So we are not considering 0. So the only solution is just pi. Pi is between 0 to 2 pi. So from here, the theta value is only pi because it belongs to our domain. This is only solution. Question number 5. The diagram shows a sector A, B, C A, B, C is a sector of a circle with the center A and the radius is R. This length radius is R and this is also R. A to C, this length is also R. Okay. The line BD, sorry, this B to D, this is perpendicular to AC. BD and AC, this line is perpendicular, and the angle CAB, where is C, A, and B? This is theta radians. This is in radians, right? Part A, given that theta is pi by 6, if when the theta value is pi by 6, right? Find the exact area of BCD. B, this is B, this is C and D in terms of R. Okay, B, C, and D, area of this region. B, C, and D, this region area. So, area of a sector, subtract area of a triangle, you will get area of this region, right? Okay, so here we can say area of B, C, D, B, C, and D, area of a sector minus area of a triangle. Area of sector ABC minus area of triangle A, B, and D. All right. Now the theta we have is given, right? Area of a sector is half radius square theta. Half radius is R and theta is pi by 6, right? Area of a triangle is half base and height. Half base times height. It is a right angle triangle, you guys can see. If I can rotate this, you guys can now understand. Now it is a right angle triangle. This length is R and the theta we have given. We need to figure out what is AD. Okay, let me draw this triangle over here. So the right angle is at D. You can see the base is DA and then this is B at the top. So B is at the top and this is A. And we don't know this length A to D. We know AB. AB is R and the angle A is pi by 6. We need to figure out what is AD, this length we need to solve. For right angle triangle, we can use the trigonometric ratios, right? So the angle, this is opposite, this is adjacent, and this is hypotenuse. So adjacent side we need to calculate. So use a ratio for cos. Cos pi by 6 is adjacent over the hypotenuse. Cos, consider triangle A, B, and D. So in triangle ABD, we can say cos of pi by 6 is the adjacent side is AD and the hypotenuse is R. Cos pi by 6 adjacent over the hypotenuse, right? So what is cos of pi by 6 in radians? This is in radian, right? Cos pi by 6 root 3 over 2. Square root of 3 divided by 2 multiply by R. This is AD. What I did, I calculated cos pi by 6 and multiplied by cross multiplied. We got the length of AD, right? Now this length of AD is root 3 over 2R. This length is square root of 3 by 2 and R. Okay. All right. Now find out the area for this segment. Now put everything area of B, C, and D would be area of a sector ABC. Area of a sector is half radius square and theta is pi by 6. Minus area of a triangle is half base times height. We have done the base and we don't know the height as well. Sorry. Or we can use the formula of half the two sides and the sine of angle between them. This is also fine. Yes. These two sides and the sine of pi by 6. Both formulas are valid over here because it is a right angle triangle. We can do half base times height or we can do half AB sine C, right? So this length is angle which two sides contain the angle pi by 6, this side and this side. So R times um, root square root of 3 divided by 2r, and sine of pi by 6. R root 3 by 2r and sine of pi by 6. This is the area of the triangle. This is pi over 12 r square minus what is sine pi by 6. Okay, sine pi by 6 is multiplying with root 3 divided by 2, and this is multiplying with 1 by 2, root 3 over 8. Root 3 divided by 8, and r times r is r square. So we need to figure out the exact area. So this would be the exact area. So the exact area is pi by 12 r square minus root 3 over 8 r square. This is the exact area. Now for part B, given instead that the length of BD is root 3 divided by 2r. Now this is given that BD, this length, B to D, is root 3 by 2r. Find the exact parameter of BCD in terms of r. Again, B, C, and D. This parameter is consisting of the length of BD, the length of CD, and the arc length, right? Now you guys can see this angle is only for part A. We don't know this value for the angle. So if I can draw this triangle over here, the right angle triangle, and solve for the value of the theta, you guys can see we have again we have the right angle is at D, and then we have A and the B. D, this is A, and this is B. Okay, so we have given B to D, this length is root 3 divided by 2r, and we have an angle A which is theta. Okay, and AB is r, this is r. We need to figure out what is this length. Okay, so for the parameter, we know the length of BD is root 3 by 2r. We need to figure out the arc length, which is radius times theta. R is a radius, solve for this theta, and we need to know this length. The length of AD, when we know AD, we can do AD minus of this length minus AD would be C to D. Solve for A to D first and theta. Two things we need to figure out here. Okay. So let me solve for theta. It is a right angle triangle, so we can do theta is opposite and the hypotenuse. So we can say sine theta, the opposite is square root of 3 divided by 2r, and the hypotenuse is r. So r is cancelled with r, theta would be equals to sine inverse of square root of 3 divided by 2. Let me solve this. Sine inverse square root of 3 divided by 2 is pi by 3. So the theta is pi by 3. We got the value for theta, which is pi by 3. When we have theta, we can say this side is adjacent. Okay, and this is the hypotenuse. Use a ratio for cos. Yeah, we can say cos of theta is adjacent side is AD, and the hypotenuse is AB, which is R. So cos pi by 3 multiplied by R is the length of AD. Okay, cos of pi by 3 is 1 by 2. So 1 by 2 R is the length of AD. Okay, now we figure out the length of AD, which is half R, and we figure out the theta, which is pi by 3. Okay, now to get the parameter, moving back to the diagram. For parameter, we need to find the arc length BC, which is radius times theta. Theta is pi by 3, right? So the arc length BC is radius times theta. The radius is r, the theta is pi by 3. So this is pi over 3r. This is the arc length, right? And we have given in the question that b to d, this length is bd, this length, root 3 over 2 pi. Now what is that length? We have AD. What is AD? We have done. AD is half r. Okay, let me solve. From the diagram, AC is the sum of AD and DC. Let me show you. A to C, this is a sum of AD and DC. We have AC is R. AD we have done is half R plus DC. Okay, so R minus half R, this is your DC. So 2 minus 1 is 1 by 2. 1 by 2 R is your DC. Now we have DC, we have BD, and we have the arc length. Just figure out the exact parameter. So the parameter of BCD, the parameter of B, C, and D is the arc length BC. This is the arc length BC, which is pi root 3, pi by 3r, and the length BD, which is given root 3 divided by 2r, and the length CD or DC, which is half r. Yeah, that is the exact parameter. All right. Question number 6. The function f is defined by f of x for x is greater than 2. Part A, find an expression for f inverse of x. Okay, so for f inverse of x, the first step is to put y equals to f of x. So we have y equals to x square minus 4 over x square plus 4. Okay, in the next step, we have to switch the variables. Y switch with x switches with y over y square plus 4, right? Now we have to do a cross multiplication. So x is multiplying with y square plus 4 and equals to y square minus 4. All right. Now we have to solve for y here, right? So xy square plus 4x minus y square plus 4 equals to 0. Shift all the terms to the left and I multiplied with x. Now combine the y terms, xy square minus y square. These are the y terms. The constant terms are negative 4 and negative 4x. Shift the 4 and 4x on the other side, it becomes minus. So let me take y square common and we have x minus 1, and let me take negative 1 common. Yes, we have 4 plus 4x. Okay, now we have y square from negative. Let me take negative here from common, 1 minus x, and here negative is common, 4 plus 4x, right? Now this negative sign is cancelled with negative sign. Y square becomes 1 minus x equals to 4x plus 4 or 4 plus 4x. You can write both. Now y square becomes 4x plus 4 divides 1 minus x, right? Now to get the value for y, we have to take a square root on both sides. The square root and the square root, and when we do the square root on both sides, the answer should mean plus minus. So the y is equals to plus minus square root of 4x plus 4 over 1 minus x. This is your f inverse of x. Now we need to decide whether it is with positive root or with a negative root, right? As we know that the domain of f of x is equals to the range of f inverse of x. Okay, Now, what is the domain of f of x? The domain of f of x is x should be greater than 2. That is the domain of f of x. So this implies what is my range of f inverse. Range of f inverse of x, this would be y should be greater than 2. This is the domain of f, which is x is greater than 2, but for the range we use a variable y that should be greater than 2. Means all the values that is more than 2, 3, 4, 5, 6, 7, up till positive infinity. So what would be your inverse function now? It should be with a positive square root, because we need the numbers which are more than 2. If the numbers are less than 2, we need a negative with a square root. This implies we can say f inverse of x becomes positive root 4x plus 4 divides 1 minus x. With the help of domain of f of x, we can easily decide the function f inverse of x, whether it is with a positive or with a negative root, right? Now for part B, show that this expression can be expressed into this form and hence state the range of f. Okay, so we have expression 1 minus 8 over x square plus 4. So cross multiplied, 1 is multiplying with x square plus 4, and minus 8 whole divides x square plus 4, right? Okay, now when we simplify, this is x square plus 4 minus 8 over x square plus 4. Now this becomes x square minus 4 over x square plus 4. Now this expression can be transformed into this form. Now the second step is to state the range of f. Now we have f of x. This is the same function f of x. You can see x square minus 4 over x square plus 4. This is your f of x. This is your f of x, and its domain we have given is x should be greater than 2. We need to find out its range. Range are basically the outputs, right? Now to figure out the range of the function, range of f of x, which is x square minus 4 over x square plus 4. Now the domain is x is greater than 2. If you give the inputs, means the x values which are more than 2, you can easily figure out the outputs, right? Okay, so if we can say let x is equals to 2, and you can solve x is greater than 2. If I can say x is equals to 2, what is f of 2? F of 2 is 2 square minus 4 divides 2 square plus 4. 2 square is 4, so 4 minus 4 divides 4 plus 4. 4 minus 4 is 0, 4 plus 4 is 8, 0 over something, the answer is 0, right? And you can see the domain is x is greater than 2, means the numbers which are more than 2 till positive infinity. So we can say let x is infinity. Let us suppose x is infinity. So infinity square minus 4 divides infinity square plus 4. Now this is infinity over infinity form. So we can write this expression as this, right? Because they are equal. So here we can say 1 minus 8 over infinity square plus 4. So this is 1 minus 8 over infinity. Something divided by infinity is 0. 1 minus 0 is 0 equals to 1. We know that infinity square plus 4, the answer should be an infinity, right? Something divided by infinity is always equals to 0, and 1 minus 0 is 1. So you can see when you put x equals to 2, the answer is 0. When you put x equals to infinity, the answer is 1. So what are the outputs? The output lies between 0 and 1, but not equals to 0 and equals to 1. Why? Because x is not exactly equals to 2. X is more than 2, so that is why it is between 0 and 1. So here we can easily state the range of f of x is 0 is less than y is less than 1. The values are between 0 and 1. So why I use the variable y for the range? Range are basically the outputs. These are the inputs. I gave some inputs and I got some outputs, so we can easily guess the range, right? Now for part C, explain why the composition f cannot be formed. Composition function is possible when the range of the inner function must lies within the domain of the outer function, right? So we can say composite function ff does cannot exist, cannot be formed because the range of inner function. What is the inner function? Inner function is f. The range of inner function f of x, that is between 0 and 1, this is the range of the inner function, does not includes the domain of outer function. Domain of outer function is your f of x, that is x should be greater than 2. You can see its range is between 0 and 1 and its domain is the numbers which are more than 2. So nothing contains, the range does not contain the domain of f. So that is why the composition is not possible. When the range of this function contains the domain of this function, then we can say the composition is possible, otherwise it is not possible. So that is the reason. Question number 7. The diagram shows the curve with equation and a line with equation. Okay, the curve and the line intersect at points A and B. Part A, find the coordinates of A and B, the point of intersection of the curve and the line basically. Okay, so for the coordinates of A and B, we need to find the point of intersection of the curve and the line. Okay, so curve is y equals to something and line is also y equals to something. Put both of them equal and you will get the coordinates. 3x minus 2 and its power is 1 by 2, and this is 1 over 2x plus 1. Okay, now in order to get the value for x, let me take a squaring on both sides. You can say squaring on both sides. So when you do the squaring on both sides, we have a square root of 3x minus 2. So take it square, and here 1 over 2x plus 1 and take it square. So this square and the square root is cancelled out. Here we are left with 3x minus 2, and he open the square. 1 square is 1, 2 square is 4, x square is x square. 1 square is 1 plus 2 into the first term into the second term. A square plus b square plus 2ab, right? I open the square. Now this and this term is cancelled. Just 1 times 1 is 1, just x is left. 3x minus 2 equals to 1 over 4x square plus 1 plus x. Okay, now shift these terms to the left side. So right side 0, 1 over 4 x square plus 1 plus x minus 3x and plus 2. 0 would be equals to 1 over 4 is a coefficient of x square. X coefficient is negative, 2 is a coefficient of x, and 3 is a coefficient. 3 is a constant term. Okay, now multiply everything with 4. So x square plus 4 times 2 is 8x with negative sign, sorry. 4 times 3 is 12 divided by 4. Now cross multiplied 4 multiplying by 0 is just 0, and 0 times 4, and this is x square minus 8x plus 12. Or we can say x square minus 8x plus 12 would be equals to 0. Okay, here we can do a factorization, right? 1 times 12 is 12. 1 is multiplying by 12. This is 12. Now find out the factors of 12. We can say 2 times 6 is 12. And negative 2 and negative 6 becomes negative 8. Right? So we can break minus 8 by minus 2 and minus 6, minus 2x, minus 6x, and plus 12 is as it is equals to 0. Take x common, we are left with x minus 2. Take negative 6 common, we have x minus 2 equals to 0. So the two factors are x minus 2 and x minus 6. This is equals to 0. Put both factors separately equals to 0. X minus 2 would be equals to 0 and x minus 6 is equals to 0. Now here the x value is 2 and here the x value is 6. Now when x is 2 and when x is 6, we have to find the y coordinate as well. So to get the y coordinate, just plug the values of x into the equation of line to get the y coordinate. Half x plus 1 is the equation of line. So we can say for y coordinates, you can put the x values into y equals to half x plus 1. Okay. Now for the first one, y would be equals to half. The x value is 2 and plus 1. So 2 is cancelled with 2. So 1 plus 1, that is equals to 2. The other one is y equals to half. The x value is 6 and plus 1. 2 times 3 would be 6 and we have 3 plus 1. This is equals to 4. Okay, now the coordinates are when x value is 2, the y value is also 2. When x value is 6, the y value is 4. Now we need to figure out which one is A and which one is B. When x is 2, when x is 6. Okay, now look at the diagram. Here the A x coordinate, we can see it should be 2 and B coordinate should be 6. It is not equals to 6. This A x coordinate is 2 and here the x coordinate is 6. So these are the coordinates for A and these are the coordinates for B. 2, 2 and 6, 4. Alright, so here the x coordinate is 2 and here the x coordinate is 6. Alright. Now for part B, hence find the area of the region enclosed between the line and between the curve and the line. Area between this curve and between the line. So when we have area between the curve and the line, we have to integrate the curve from 2 to 6 and then subtract the integration of the line from 2 to 6. We have both equations, right? Because this area is between the curve and the line. So curve is at the top, so curve subtract line. If line is at the top, then we do line subtract the curve. Okay, so that area becomes integration from 2 to 4 or 2 to 6, sorry, from of the curve is 3x minus 2 whole power 1 by 2 with respect to dx minus integration from 2 to 6 of the line, which is half x plus 1 with respect to dx. This would be the area. Let me do the integration. Now the area becomes, applying the power rule of integration, 3x minus 2 power plus 1 divides power plus 1, multiply 1 over the derivative of this function is just 3 and the limits we have to apply from 2 to 6, minus this is 1 over 2 x integration is x square divided by 2 plus 1 integration is just x and limits are from 2 to 6. Okay, we have to do further simplification and here the area becomes 3x minus 2 and its whole power is 3 by 2 over 3 by 2, multiply 1 over 3 and the limits are from 2 to 6, minus x square divided by 4 plus x and the limits are from 2 to 6. Okay, one more step, 3x minus 2 before substituting the limits, multiply 1 over 3 and this is 3 by 2, so we can write this down as 2 by 3 and from 2 to 6 subtract x square minus 4 divided by 4 plus x from 2 to 6. Alright, so this is 2 over 9. Okay, and 3x minus 2 to the power 3 by 2, applying the limits from 2 to 6. minus we have x squared divided by 4 and plus x. Now we can do the limits. Okay, applying limits. So when we apply the limits, the area becomes, the upper limit is 6 and the lower limit is 2, right? So 2 over 9, applying the upper limit first. 3 times 6 minus 2 and its power is 3 by 2. Subtract, the lower limit is 2 by 9. 3 times 2 minus 2, the power is 3 by 2. Minus this function upper and the lower limit. Upper limit is 6, 6 square over 4 plus 6. This is upper limit. Minus the lower limit is 2, 2 square divided by 4 plus 2. Okay. Now simplify it further. The area becomes, let me simplify it. 3 times 6 minus 2, 16. Its power is 3 by 2. Multiply by 2 and divided by 9 is 128 over 9. 128 over 9. And 3 times 2 is 6. Minus 2 becomes 4. And the power is 3 by 2. Multiply by 2 and divided by 9 is 16 over 9 with negative sign. Minus, simplify this bracket, 6 square divided by 4 plus 6, 15, and 2 square divided by 4 plus 2, 3, negative 3. Simplify, the denominator is same, 128 minus 16 divided by 9. So 112 over 9. And this is 15 minus 3 is 12, so negative 12, right? 112 divided by 9 and minus 12, this would be 0.4444. Or we can write in exact form as well. 9 times 12 cross multiplied 108. So 112 minus 108 divided by 9. From 112 subtract 108. This is 4. So 4 by 9. So that area of that region is 4 by 9 or 0.444. 0.44444. Right. That is the area. Question number 8, part A. The curve y equals to sine x is transformed to the curve y equals to 4 sine half x minus 30. Okay, describe fully a sequence of transformation that have been combined, making clear the order in which the transformations are applied. Okay, so the base function is y equals to sine x. So the first transformation we have to apply on the function is we have to multiply 4 with that function. So this 4 is basically the horizontal, the stretch in y direction by a factor of 4. So the first transformation is stretch in y direction by a factor of 4. Okay, so when we have a stretch in y direction by a factor of 4, so y would be equals to 4 sine x, right? Okay, the second transformation is 1 over x, 4, 2 is multiplying with x. So this is a stretch in x direction by a factor of 2, the reciprocal. So stretch in x direction by a factor of 2. So when we have a factor of 2, then we need to write down the reciprocal of 2 is 1 by 2. So y is equals to 4 sine 1 over 2x. So with x, just that factor is multiplying. Now it is negative 30 as well. With x value, it's negative 30. Okay, so if it is negative 30, so you can see this thing is only with x. So we have a horizontal translation 30 units to the right. It's negative, so it's right. If it is positive, it's towards left. Okay. The third transformation is horizontal translation 30 units right. So the matrix is 30 and 0. There is no vertical translation. The horizontal translation is just 30. So we can write this down: y equals to 4 sine 1 over 2x subtract 30 degree. Okay, so keep it in mind, anything multiplying with the whole function, this is your stretch in y direction. Anything multiplying with just the x value is a stretch in x direction, but we have to write down the reciprocal. Anything add or subtract with the x value is a horizontal translation. If it is positive, towards left. If it is negative, it's towards the right. So these are the three series of transformations. Now for part B, find the exact solutions of the equation. This whole equation equals to 2 root 2 from the x is between 0 to 360 degrees. Okay, simplify. So we can say sine half x minus 30 degree. This would be equals to 2 root 2 divided by 4. 2 times 1 is 2, 2 times 2 is 4. So this is root 2 over 2. Now this equation tells us that sine is positive, right? So the first thing is to figure out the base angle. Now the base angle is half x minus 30 degree. This would be equals to sine inverse of root 2 over 2. This is in degrees, right? Your calculator should be in degree mode. My calculator is in radian mode. Let me put it to degree mode now. Sine inverse square root of 2 divided by 2, 45 degrees. So this is your base angle. Base angle is 45 degrees, right? Now this is from 0 to 360 degree. Now we need to figure out from 0 to 360 degrees sine is positive in which quadrant according to the coordinate diagram. So let me make this diagram. Okay. So in the first quadrant, all trigonometric ratios are positive. Here sine is positive, here tangent is positive, and here cos is positive. This is the base angle. Here we do 180 degree minus the base angle. Here we do 180 degree plus the base angle, and here we do 360 degree minus the base angle. Now in from 0 to 360 degree, sine is positive in the first and in the second quadrant, right? So sine is positive in first quadrant. Since sine is positive in the first quadrant, so what is the value for theta? The theta should be equals to your base angle, right? So this whole thing is your base angle. So what is theta in this case? This is your theta. So this theta, which is half x minus 30 degree, is your base angle, which is 45 degrees. Let me simplify. So half x equals to 45 degrees plus 30 degrees. 45 plus 30. 45 plus 30 is 75 degrees. So what is x? We have 2 times of 75 degrees cross multiplied basically. Times by 2 is 150 degrees. Okay. So here the x value is 150 degree. This is your first solution, which is in between 0 to 180 degree, right? Okay. Now the second thing, for sine is also positive in the second quadrant. For the second quadrant, what is the value of theta? The theta value is 180 minus that base angle. So this is your theta now. So this is half x minus 30 degree would be equals to 180 degree minus this base angle, which is 45 degrees. Okay. So from 180 take away 45, 180 minus 45 is 135 degrees. So half x minus 30 degree is 135 degrees, right? So half x would be equals to 135 plus 30. 135 add 30 is 165. So we have half x is 165 degrees. So what is your x? X is 2 times of 165. So times it by 2, it is 330 degrees. So the x value is 330 degrees, right? So these are the two solutions which are between 0 and 360 degrees. 150 and 330. 330 and 150 both are in the range of 0 to 360. Question number 9. The equation of circle is part A. Find the coordinates of center of the circle and the radius. Hence, find the coordinates of the lowest point on the circle. Okay, so first figure out the center and the radius and then the lowest point. Okay, so for the center and the radius, it is better to convert the equation of circle into its standard form. So complete the square x square plus 6x. Combine the x term, y term is y square minus 2y, and the constant is minus 26 equals to 0. Now complete the square of x. This is x whole square plus 2 times x times what makes 6x. A square plus 2ab, right? 2 into a term is x, right? And b is 3. 2 times 3 is 6. Plus 3 square and minus 3 square. Now with y terms, we can say y square minus 2 into y into 1 makes minus 2y plus 1 square and minus 1 square, and negative 26 is as it is. Okay, now combine the first three terms. This is a square plus 2ab plus b square. This is a plus b whole square. 3 square is 9. And here y minus 1 whole square minus 1 square is 1 minus 26 equals to 0. Minus 26 minus 1 and minus 9. Minus 26 minus 1 minus 9 is minus 36. So x plus 3 whole square plus y minus 1 whole square equals to 36. It's negative 36, so shift on the other side becomes a positive 36, right? Now this is in standard form. We can easily figure out the center of a circle. So the center of this circle is negative 3 and 1. And we can easily get the radius of a circle is equals to 6. Root of 36, which is equals to 6. Okay. Now we get the center, the coordinates of center and the radius. The next thing is to figure out the lowest point. If I can write down into standard form x minus a whole square plus y minus b whole square equals to the radius square, right? Okay, so this is x minus 3 whole square plus y minus 1 whole square equals to the square root of 36, which is equals to 6, because 6 square gives you 36, right? 36. So something square is 36. So this r is your radius, which is 6. Okay. Now the next thing is to find the lowest point. Okay. For the lowest point, we need to figure out if we can draw that circle. Okay. Okay. Okay, right. So the center of that circle is negative 3 and 1. So x coordinate is negative 3, the y coordinate is 1. Let's say this is the y coordinate 1, and negative 3 we have to move over here. Okay, you guys can see this and this, it's 1. And now we can decide the same thing on the other side. So negative 3, negative 1, negative 2, and negative 3 is over here. So this coordinate is negative 3 and 1. So this point minus 3 and 1. So from this center, if you move, the radius is 6. 6 unit up, you will get the highest point of the circle. And when you move 6 units down, you will get the lowest point of that circle. Okay, this is basically in order to visualize the situation, right? So I first label the center of the circle, right? To get the right point, just move 6 units to the right. To get the left point, move 6 units to the left. To get the highest point, 6 unit up. To get the lowest point, 6 units down. Why I'm saying 6? Because the radius is 6, right? So if you move 6 units down, we have 0, negative 1, negative 2, negative 3, negative 4, negative 5. So from this point, if you move 6 units down, it becomes 1, 2, 3, 4, 5, 6. So this would be the point. And the coordinate of that point is negative 3 and negative 5. So when you move 6 units down. So from here, we can say that the coordinates of the lowest point on the circle are negative 3 and negative 5. These are the coordinates of the lowest point of the circle. I hope this is clear now. Now for part B, find the set of values of constant k. The set of values we need to figure out for the constant k, for which the line with equation intersect the circle at two distinct points. Okay, the line intersect the circle at two distinct points. It means their discriminant should be greater than 0. If it is greater than 0, then we have two solutions, right? Okay, so first thing first, find out the point of intersection of curve and line. So what is the curve? The curve is a circle, right? So the equation of circle is x plus 3 whole square plus y minus 1. So this is your y, which is kx minus 5, and negative 1 whole square equals to 36. This would be the equation of circle. Let me rewrite: x plus 3 whole square, y minus 1 whole square equals to 36. That is the equation of circle, and this is the equation of line. I just substituted the y value over here, right? Now open the squares, right? So this is x plus 3 whole square, and this is kx minus 6 whole square equals to 36. X square plus 2 times 3 is 6x, 3 square is 9, plus k square x square minus 2 times 6 is 12 kx, 6 times 6 is 36 equals to 36. Okay, now combining the square x square terms, x square plus k square x square, the x terms are from 6, and this is 6x and minus 12kx, and the constant is 9 plus 36, and shift the 36 on the other side, minus 36. This is just 9. Now the x square coefficients are 1 plus k square. The x coefficients are 6 minus 12k, and the constant term is just 9 equals to 0. The discriminant should be greater than 0. Let me solve the discriminant. Now we can say b square minus 4ac should be greater than 0. Now what is a? A is a coefficient of x square 1 plus k square. B is a coefficient of x which is 6 minus 12k, and C is a constant term which is 9. Substitute everything. So B is 6 minus 12k and its whole square minus 4. The A is 1 plus k square and the C value is 9. This is greater than 0. Now open the square. 6 square is 36 plus 12k whole square. 12 square is 144. K square is k square minus 2ab minus 2 into 6 into 12k minus 144k. 4 times 9 is 36 times 1 is minus 36 plus minus 36k k square. So 4 times 9 is 36 with a negative sign is minus 36 is multiplying with 1 and minus 36 is multiplying with k square. This should be greater than 0. Now positive and negative 36 is cancelled out. K squared are these two, 144 minus 36. 144 minus 36 is 108 is a coefficient of 8k square, and this is a k term minus 144k. This is greater than 0. Okay. Now we can take a common. 108k minus 144. This is greater than 0. Now let me find the factors by putting both of them equal, right? So k is equals to 0, or we can say 108k minus 144 is equals to 0. So here 108k equals to 144 and k would be equals to 144 divided by 108. 144 divides 108. This is 4 by 3. So k value is 4 by 3. So these are the two k solutions. K is 0 or k is 4 by 3. Okay. We need to find the set of values of k, right? Okay, so now here we consider this is a quadratic equation in a variable k and its leading coefficient is positive. So the opening of the parabola is upward. Let me draw the parabola here. So if I can draw this parabola, its opening is upward, right? Okay. With this equation, we come to know that it's a quadratic. Graph is a parabola. Opening is upward because k square coefficient is positive, right? Now the two roots are 0 and 4 by 3. What is 4 by 3? 1.3. Okay. So this is 0 and this is 4 by 3. Okay, so these two roots we need to guess that when it is greater than 0, at what point it is greater than 0. This parabola is more than 0. It is greater than 0 when this is k, basically this is k and these are the y values, right? Now when this is greater than 0, when the k values are less than, it is positive, right? Its parabola is positive. When the this is k axis, right? When the k values are less than zeros and when the k values are more than 4 by 3. This show that the values are more than 4 by 3 and this shows that their values are less than 0, right? So these are the two set of values of k. K should be less than 0 and k should be greater than 4 by 3. These are the solutions, set of values of k when it has two distinct points of intersection. Question number 10. The equation of the curve is such that we have given the second derivative. A curve has a stationary point at -1 and 9 by 2. These are the coordinates of the stationary point. Part A. Determine the nature of the stationary point at -1 and 9 by 2. The nature of the stationary point. For the nature of the stationary point, we have to put the stationary point x equals to -1 into the second derivative. If it is positive, then that stationary point is minimum. If the answer is negative, the stationary point is maximum. So into the second derivative d2y over dx square, we have to substitute x is equals to negative 1 because the x coordinate of the stationary point is negative 1. 6 into negative 1 square minus 4 over negative 1 cube. This is 6 minus 1 square is minus 1. 1. 4 over negative 1 cube is negative 1. 6 times 1 is 6 plus 4, that is equals to 10, and 10 is greater than 0. So we can say this point is minimum. This implies the stationary point minus 1 and 9 by 2 is minimum because the second derivative is positive. When the derivative is positive, the nature is minimum. When the derivative is negative, the nature is maximum. Now for part B, find the equation of the curve. So get the equation of curve, just write down the second derivative d2y over dx square equals 6x square minus 4x to the power negative 3. Right? I shifted the x cube into the numerator. Now, in order to get the equation of curve, first we have to reduce the second derivative to the first derivative by integrate both sides with respect to dx. Integrate with respect to dx. Okay, so one derivative is cancelled with one derivative, one dx is cancelled with dx, so dy over dx is left. And here 6x square integration is x to the power 3 over 3 minus 4, here x to the power minus 3 plus 1 over minus 3 plus 1, and plus some constant of integration. Okay, now we have to simplify dy over dx. This is 3 times 2 is 6, so 2x cube minus 4x to the power negative 2 over negative 2 plus c, the constant of integration. 2 times 2 is 4 and negative negative makes positive. So dy over dx, this is 2x cube plus 2 over 2x to the power minus 2 plus c. Now to get constant of integration, we have to use the point that the stationary coordinates of stationary point are minus 1 and 9 by 2, right? Now as we know that for stationary point, the first derivative should be equals to 0 and you get the x coordinate which is negative 1, right? So when you put the first derivative equals to 0 and the x value equals to negative 1, you can easily get the constant of integration. So let me do this. This is 0 to negative 1 cube plus 2 negative 1 to the power negative 2 plus the constant of integration. So this is 0. Okay, 2 into minus 1 to the power 3, which is negative 2 plus, sorry, this is minus 2. 2 into minus 1 to the power negative 2, it's just 2 plus the constant of integration. 2 and minus 2 is cancelled out, so the constant of integration is 0, right? We got the constant of integration, that is 0, so plug the c value over here. So dy over dx becomes 2x cube plus 2x to the power minus 2. This c value is just 0. Now we have to reduce it one more time by taking integration with respect to dx on both sides. To get the equation of curve, dx and dx is cancelled, derivative is cancelled with integral, we are left with y equals to 2x to the power 3 would be 4 over 4 plus 2x to the power minus 2 plus 1 over minus 2 plus 1 plus the constant of integration c prime. Okay. Now here y would be equals to x 4 over 2 times 1 is 2, 2 times 2 is 4 minus 2 x to the power minus 1 and plus 2 divides minus 1. Minus 2 plus 1 is minus 1 plus c prime. Further simplification, we have y equals to x 4 over 2 minus 2 over x plus the constant of integration. Minus 2 and this x shift to the numerator becomes 1 over x, right? Now, as we know that the coordinates of the stationary points are -1 and 9 by 2. Stationary point is basically the turning point. And turning point or stationary point must lies on the curve. So if it lies on the curve, some point lies on the curve, it must satisfy the equation of the curve. So just plug the values and get the solution. So the y value is 9 by 2, the x value is -1 to the power 4 divided by 2 minus 2 over -1 plus the constant of integration, right? This is 9 by 2 and this is 1 over 2 because -1 to the even power is positive. This is plus 2 plus c prime. So 9 over 2 minus 1 by 2 and minus 2, this would be your constant of integration. Let me simplify. 9 by 2 minus 1 by 2 and minus 2 is 2. 2 is the constant of integration. 2 is your c prime. Now we have the equation of curve becomes y equals to x4 divided by 2 minus 2 over x plus 2. I just plug the value over here in this equation. So that is your equation of the curve. Now for part C, show that the curve has no other stationary points. Okay. So in order to prove that the curve has no other stationary points, we know that for to get the stationary point, we have to put the first derivative dy over dx is equals to 0, right? So what is dy over dx? This is your dy over dx. Yeah, this is your dy by dx when the c value is equals to 0. So dy by dx is basically 2x cube plus 2 over x square. This is equals to 0. Alright. So simplify 2x cube would be equals to minus 2 over x square. This 2 and this 2 is cancelled out, right? X cube equals to minus 1 over x square. Shift this on the other side, x cube into x square equals to -1 or x to the power 3 plus 2. Bases are same, we have to add the powers. This is x to the power 5 should be equals to -1, right? When you have x to the power 5, so taking a fifth root on both sides, right? So x to the power 5 and its whole power is 1 over 5. This is -1, its whole power is 1 over 5. And here you have x coordinate is, you can do -1 to the power 1 by 5 is -1. This is -1. This implies that x equals to -1 is the only stationary point. There are no other stationary points. No other stationary points. Now for part D, a point A is moving along the curve and the y coordinate of A is increasing at a rate of 5 units per second. The y coordinate at a rate and 5 units per second. The derivative of rate means the derivative of y with respect to time is 5 because it is increasing. So what we have given that the derivative of y with respect to time is equals to +5 because it is increasing. Find the rate of increase of x coordinate of a at a point where x is equals to 1. We need to figure out dx over dt and when x is equals to 1. Okay. So to get dx over dt, apply the chain rule. So the chain rule says dx over dt, this should be equals to dx over dy into dy over dt. Okay, we have dy over dt which is 5. We need to find out dx over dy at x is equals to 1. Okay, so what is your dx over dy? Okay, this equation is your dy over dx. Dy over dx is this thing, right? So dx over dy, take a reciprocal basically. Okay. Dy over dx. When you do the reciprocal of this side, this whole thing divides 1. The reciprocal of the other side, which is 1 over 2x cube plus 2x to the power negative 2. Let me solve this at x is equals to 1. So when x is equals to 1, dx over dy, this becomes 1 over, it's 1, right? 2 plus 2, because 1 to the power 3 is 1. 1 to the power minus 2 is 1. 1 to any power is always equals to 1, right? So this is 1 by 4. So just put 1 by 4 and this is 5. Now we have dx over dt. This becomes dx over dy is 1 by 4 and dy over dt is 5. We got this is 5. So multiplied by 5. So this implies dx over dt, this is 5 over 4. This is a rate of increase of x coordinate of a at the point where x is 1. Alright, so that is the last question of our paper. If you have any queries, please let me know in a comment section and please subscribe to my channel. Thank you for watching. See you next time. Take care.